Hey guys, this is Mainak, your Swill Bros. So today, what we're going to do is we're going to understand how to find out the centroid and the moment of inertia, and we're going to do some numericals to just verify our concepts. So this can be important for any competitive exams or even for your regular curriculum. And if you understand this concept, you can move a little bit deeper. So this is the second lecture on the strength of materials, and we'll dig a little bit deeper. And after just watching this and solving this by yourself, I hope that you'll be able to find out the centroid and moment of inertia of any section. So let's get started.
Start with the centroid and the moment of inertia. So first of all, let's draw a figure, normal figure. Let's draw a rectangle first. So this is the normal rectangle, and let this dimension here be your D, and this dimension be here B. So now if we find out the centroid first, so generally the centroid in this direction will be your D by 2, and this is also called the can be called the y bar, and the centroid in this direction is your b by 2, it can be called x bar. So why this is x bar and y bar? Because generally we are taking the axis like this. In this axis we are taking x, and this axis we are taking y. This is general convention used in almost all the structures. So this is the basic centroid for the rectangle. So similarly, if we draw another rectangle here, suppose here this I'm drawing this type of rectangle. So there is an axis here which can be called the neutral axis, and after that in this, if I draw this axis is the x and this is the y. So whatever this is, it is your D, and this is your B. So similarly, the y bar will be equals to D by 2 and x bar equal to B by 2. So this is the general things which are used for the rectangular section. For the centroid, it is pretty easy. So now what happens if we have a different kind of structure? Let's say we have this like this L section. So basically it is made up of two rectangles, so you have to know that. So let's just give some dimensions to this L section, and we can just divide this L section in two parts, let's say 1 and 2. And this 1 and 2 will obviously have its B and D individually. So for this particular one, this will be the B, okay, for the 1, and this will be the D, okay. And for the 2, suppose 2 for the 2, this will be the B, okay. B is along the x-axis, parallel to the x-axis is B, and parallel to the y-axis is D. So it is your D. So for convenience, you can write here it is B2 and D2, it is B1 and D1. So you can write like this, just in case, okay. So this is the how you divide these two parts. And when you divide these two parts, you can also write the formula for this y bar, okay. Y bar, that is the centroid along the y direction, and the centroid along the x direction. So y bar, or the centroid along the y direction, is your a1 y1. So what is a1? A1 is the area of your one part. So a1 basically is equals to b1, that is this one, into d1. Similarly, a2 is equals to b2 into d2. So a1 y1 plus a2 y2 divided by a1 plus a2. So if there are up to n number of terms, if there is three items like this, so it will be a3 y3 by a1 plus a2 plus a3, like this it will go on, okay. Similarly, x bar, or the centered in the x direction, it is a1 x1 plus a2 x2 and divided by a1 plus a2. So this is pretty simple. So to understand this logic better and to register it, we'll do a numerical. So let's do a numerical here. Let's just make an L section like this, and let this be 40 mm, okay, and this is 160 mm. So this is what is given in the question, and we also need this dimension here. This is your 120 mm, and this is your 40 mm, okay. So now you have to find the centroid here. So that will be the question, find the centroids, okay. Find the centroids in x and y direction. So that will be the question. So what will be your answer? So first of all, in the answer, you'll just simplify the figure a little bit. So in the question it is given here, just redraw it. Question is given that this is 40 and this is 160. So we'll just first of all divide the figure. Let me just take this as 1 and take this as 2. Okay, and this is given here 40 and this is given here 120, right? So if the total is 160 here and this is 40, so this will be 160 minus 40, which is 120. So for me, we know that here we can write this here also. Here b1 is equals to 40, your d1 d1 is equals to 120, and b2 is equals to 120, and d2 is equals to 40. So you know that right now. So similarly you can just find out the a1 and a2 from here. A1 equals to b1 into d1. Okay, I'll just write it once just for sake, and we can find out the value here. So a1 will be 40 into 120, it is equals to 4800 mm square. Similarly a2 will equals to b2 into d2, and it will be equals to 120 to 40, again same answer will be there, 4800 mm square. So this will be the answer. Now you need to find out the y1 and y2. Okay, so now this is interesting. So to find out y1, so y1 you have to take a point where you take the 0, that is the starting point. So y1 for this is 120 by 2 here, which means 60, but you are starting from here. Originally you are taking from here, because all the measurements you have to take from here, so you have to add this as well, 60 plus 40. So we have to add this 40 mm as well. So we write here 40 plus 60. So your y1 is equals to 100. Similarly there should be your x1 as well. So x1 is equals to, since this is starting from here, so there is no problem here. X1 is equals to 40 by 2 is equals to 20 mm. So there is no problem in y1 x1, and then there is your y2. So for the y2 it is 40 by 2. So y2 is 40 by 2 is equals to 20 mm, and for the x2 is starts from here, so it is 120 by 2, it is 60 mm. So once you have written all this, now simply you have to put it in the formula. So what is the formula? Y bar equals to a1 y1 plus a2 y2 by a1 plus a2. So if you put all this together, just write the value here, 4800 mm square into y1, that is 100, plus a2, that is 4800 mm square, into your y2, that is 20, and divided by a1 plus a2. So this unit will be mm cube, and the bottom will be mm square. A1 plus a2 is basically 4800 into 2, right? So the answer will be in mm, and the answer will be 60 mm. Similarly x bar is equals to a1 x1 plus a2 x2 by a1 plus a2. So if you just compute this, the value will come as 40 mm. So this is the answer. So this is a simple numerical. So if you understand this, then you will be able to do most of it. So let's see. Let's just clarify our concepts and do some more numericals. So if you want to just see whether your concepts are okay or not, you can just pause the numerical, because that is all the concepts you require for solving for the rectangle, T section, I section. Just you can pause the this video and then do it yourself, and then check the answer. Okay, so let's take an I section here, right? So this is an I, and these questions are also very common here. So this is an I. So the dimensions, this is 100, this is 20, and this is 150, right? And this is again 20, the web, and this is 30. So that's what it is given here. And now this you have to determine the position of the center of the whole I section. So the question is, determine the position of the centroid, right? So position of the centroid for the I section, you can say for the I section, right? So now let's first of all just gather all our information which we have. So first of all you need to mark this, okay, in three parts. So I'll start from the bottom. Let me do this 1, let me do this 2, and let me do this as 3. So here in the first one, let's do here, you know, your a1, okay. A1 is equals to 150 into 30. We'll just write this, you know, directly. 150 into 30, we'll just calculate it and write this directly, because we also want to solve the numerical in the least number of steps as possible. 45500 mm square. Here we're okay with that. And then your a2 is equals to here 20 into okay, I think we have missed a dimension, the which is given in the in the question. So this particular dimension which is there, we have to just write the, so this is 250, this is given in the question actually, this part, this is 250, okay. So a2 is equals to here 250 into 20. So this will be 250 into 20, and it will be 5000 mm square, 5000 mm square. And a3 is equals to here 100 into 20. So 100 into 20, it will be 2000 mm square. So this will be it. And let's also do the x1 and x2. So you can see here 100 is less than this, so the 0, you can assume at this point the 0, and if you just assume the 0 at this point, and you will have here just a center like this. And if you have the center at here, so 100 by 2 will be on this side and 100 by 2 will be on this side. So since this will be similar, so 100 by 2 is 50. So if this particular distance is your 50, then your this distance will be 50 minus 20 by 2, 50 minus, that is 50 minus 10, so this will be 40. Similarly, this distance will be, this particular distance, this will be your 150, right, 150 by 2, that is 150 by 2. If you just make it 150 by 2, that is 75, 75 minus 10, that is 65. So this distance will be 65. So this is very important, this concept is very important. If you don't understand, then I'll just just draw it again, just to not make it more clumsy. Many people might not get it, so I'll just draw it again. And I could take it directly through the similar axis theorem, but for explaining I'm doing this. So now what is given here, this is 100 given in question, right? This is 100 given in question. This is your 20. So we know that this, if passes through the center, this is 10, and if this passes through the center, this is your 50. So what will this be? 50 minus 10, 40. Similarly, this one will be 65, right? This is 150, this is 30, right? 150 by 2, this is 150 by 2, and 150 by 2 is equals to 75. Now 75 minus 10 is 65. So like this we got this, okay. So I'll write here x1 first, okay. X1, let's write x1 first. So x1 will be here 150 by 2. So 150 by 2 is equals to 75. Let's write y1. Y1 will also be easy, 30 by 2, that is 15. The unit is mm, 15 mm. Now let's go for x2. Now when you go for x2 here, remember that we are talking about this. So it will be 65 plus 20 by 2. So it will be your 65 plus 10. I'm just write this, plus 20 by 2 is equal to 65 plus 10, that is 75 mm, right? And y2, okay, y2. So y2 will be 30 plus your 250 by 2. So I'll also write it here, 30 plus 250 by 2. So y2, if you just calculate 250 by 2, that is 125 plus 30 is equals to 155. So it will be 155 mm. And then comes x3. So x3 is equals to, so what will x3 be? X3 will be the difference between these two, because this is 65, this one, and this is 50. So the difference is 15, right? So x3 will be your 65 minus 50, right? We have to, sorry, it's not 65 minus 50, it's 65 minus 40. This is 40 mm, the difference. So it's 65 minus 40. I'll just write it here. 65 minus 40 plus the half plus 50, right? Plus 50, and this will be equals to 75. So if you didn't get it, I'll just do it again. So basically you see, we are talking about this section. This is a 3 number section. The half is actually 50. Now the origin we are taking it from here, so we have to add this distance, this particular distance, this difference to the 50. So what we are doing, 65 minus 40, that is 25. So 25 plus 50, so that is what we are writing here. 25 plus 50 is equals to 75 mm. Similarly, if you go for y3, y3 is pretty much easy, because with 30 plus 250 we have to add first blindly. 30 plus 250, adding blindly, and then you have to go for the this particular your b3 by 2. Okay, so it is 20 by 2, so it is 10. So if you just add all this, that is 30 plus 250 plus 10, it will be 290 mm. So these, once you get it, then the formula for applying this shouldn't be a great deal. So similarly use the formula x1 equals to a1 x1 plus a2 x2 plus a2 x3 by a1 plus a2 plus a3, right? If you just calculate the value, it will be your 75 mm. And similarly, if you calculate the value of y1, sorry, y bar, sorry, it will be x bar and y bar will be 123.70 mm. So this will be the answer for this question. So now I guess you have grasped the concept of your centroid. So now let's move into moment of inertia, so which is simply an extension of this centroid concept. So this is just similarly the next part. Okay, so suppose you have this section here, and let's take an L section to start with. Okay, and for this L section we already know that if you divide this into, let's say, 1 and 2, then this one will be the B1, this one will be D1, and similarly this one will be the D2, and this one will be the B2, right? So we know all these things. So when it comes to these moment of inertia, it will be your, what it will be, let's take the moment of inertia along the x-axis. So ixx, suppose for any particular this thing, so let's take ixx1, let's for example 1 by 12, right? 1 by 12 b1 d1 cube, plus b1 into d1, right, into your y minus y, that is y1 minus y bar. So this is interesting. So suppose this I'm taking the moment of inertia of this particular part, and then this formula will be like this, and total ixx moment of inertia along the x-axis will be ixx1 plus ixx2. So ixx2 will be also similar, just it will be b1 d1, b2 in place of b1 and d2 in place of d1, and y this y2 in place of y1. Okay, so it will be like this. So you can note here that here we are using this will not be there, it will be simply be y1. Okay, not y bar, it's simply y1. Okay, so in the x direction we are using y, and in the y direction for the y formula we will similarly use x. So this is pretty simple. 1 by 12 BD is for the rectangle, and then b into d into your y minus y bar. So similarly, when we take for I y1, then the b and d will get changed, right? The b will become d and the d will become b. So like this you can remember it very easily. So if you just do one numerical, then all your concepts or doubts which you are having at this point will be clear for the moment of inertia, and the unit is your length to the power 4, that is it can be meter to the power 4 or mm to the power 4, right? So let's do a numerical to solve our doubts. So let's take here a very simple numerical and start with an L section, right? Now this is 80, this is 10, and this is 60, this is also 10. So now this is all given in the question, and find your mi, or the mi is not Mumbai Indians, it is moment of inertia. Okay, so right now just take this, let's take here and draw our figure here. So basically we draw this figure once again, and we'll do this 1 and we'll do this 2, and we'll find out, okay, this portion is your 70 mm, so that's what you need to find. And here we'll just write our x1 y1, so very similar, we'll find x bar and y bar. So x bar and y bar first, and after that we can do all the things, right? So first of all, let's do here x1. So now what is x1? X1 is equal to, just take the origin at this point 0 comma 0, let's assume at this point. So x bar is equals to 60 by 2, so it is 30 mm, and y1 is equals to 10 by 2. Okay, 10 by 2 is equals to 5 mm, and then a1, so a1 is basically x1 into y1, so it is 30, sorry, not x1 into y1, b into d, that is 60 into 10, 60 into 10, so it is basically 600 mm square, right? So b into d, 600 mm square. So similarly x2, and let's write the x2 as well. X2 is equals to, so x2, for the x2 it will be 10 by 2, it is 5 mm, and y2 it will be 10 plus, I'll just write it here because some 10 plus 70 by 2, right? So it will be 10 plus 35, it is 45 mm. Similarly a2 is equals to your 70 into 10, that is 700 mm square, right? 700 mm square. So now let's calculate x bar, right? So x bar formula we already know, x bar equals to a1 x1 plus a2 x2 by a1 plus a2, right? Let's put all the values together and then calculate. So it is equals to your 600 mm square into x1, that is 30 mm, and plus a2, that is 700 mm square, into x2, that is 5 mm, divided by a1 plus a2, that is 600 plus 700 mm square. So we just calculate. So if we calculate this, this will come as your 16.54 mm, right? And then you go for the y bar. Okay, y bar you calculate in the same process, a1 y1 plus a2 y2 by a1 plus a2. You do this, it will come as 26.54 mm, right? So now comes the moment of inertia. Okay, so for the moment of inertia, ixx1 equals to 1 by 12 into b1 d1 cube. So now you can write the formula if you want. It's okay, I'm doing for the first time. Let's write the formula, b1 into d1 cube plus your b1 into d1 into your, since this is x, it will be x1, there will be y1 minus y bar, right? So this is the formula, y bar whole square, right? I had written the formula correctly. Yeah, okay, I had missed that part. It will be y minus y1, this will be whole square, right? So this is the formula, 1 by 12 bd cube plus b into d into y minus y1 whole square. So now for this, it will be, let's write the values here, 1 by 12 into your b1. So now for this one, we are taking b1 is equals to 60, and d1 is equals to 10. Okay, so it will be 60 into 10 cube plus 60 into 10 into y1. Let's see what is the value of the y1 which is written here. Y1 is 5, right? So it is 5 minus y bar is 26.54. So you can write here 26.54 whole square, right? You can write the opposite also because it is square, so you can write 26 minus 5 also, just doing it for explaining. So you can just write this value. So answer will come around your 28382.96 mm to the power 4, right? So now ixx2, let's just do this as well. It will be your 1 by 12, only in place of b1 it will be b2, and in place of d1 it will be d2. Okay, so you can write the formula once again. The more you write, the more you'll remember. Okay, b2 into d2 cube plus b2 into d2 into y2 minus y bar whole square. Okay, so it will be 1 by 12 into b2. So what is b2? b2 is, you can see in this figure, we have already written here. So a1, if this b2 is here 10, right? b2 is 10 here in the for the part 2, and d2 is 70. Okay, 10 into 70, so this is sorted. So you can write here b2 is 10 into 70 cube plus your 10 into 70 into y2 you can just check out from here. Y2 is your 45 mm. So now it is 45 minus your y bar already you had calculated here 26.54. So it is y 45 minus 26.54 whole square, right? So if we just calculate this value, it will come as your 524,373.45 mm to the power 4. So now ixx, if you calculate, it will be ixx1 plus ixx2. So it will come as 807756.41 mm to the power 4. So this will come as the result here. Similarly, you can go for iy1 and iy2. The same thing will be there, but here there is a twist. b1 d1 will change. Okay, let's write here I yy1. So it will be 1 by 12 into bd cube plus b into d into your x1 minus x bar the whole square. So now it will be all the same. What you need to do is 1 by 12 into, so similarly just look into the previous ixx1, what it did 16 to 10 cube. Right now do the opposite, right? 10 into 60 cube, because this is taken in the y-axis, so these are the opposite. So similarly plus 10 into 60 into x1 minus x bar. So x1 you can already check it from here. X1 we already written 30 mm, and x bar is 16.4. So 30 minus 16.4, we can write here 30 minus 16 point your, so what was the value here? 30 minus 16.54, sorry, 16.54. So you can write the result here 16.54 the whole square. So if you calculate, it will come around 289,350 mm to the power 4. And if you calculate the iyy2, similarly you will do 1 by 12 into b2 d2 cube. So just take the opposite, 70 into 10 cube, right? 70 into 10 cube plus 70 into 10 into this this will be, let's check out y2. So if you check out y2 in the given in the which we have taken, it is your, okay, let's check y2 here. What is the y2 here? Sorry, not y2, we'll check the x2 here. So it will be your 5 mm. So it is your 5 minus 16.54 whole square, right? So it is I'll just write it here because it is x2 minus x bar, right, whole square, right? So this is there, and if you just calculate it, it will be 98,408.33 your mm to the power 4. So like this, if you just add it, iyy equals to Iyy1 plus Iyy2. It will come as 387758.33. Your answer may have some variations in the decimal, so that won't matter, but I hope you have got the concept of this. So like this you can calculate the moment of inertia. So now let's do one here question which you can do at home, and then if you are having any difficulty, then I can give you the solution to this. Okay, so let's write the question here. So we'll go with the T section this time, right? So let's go with the T section, and simple T section here. This is 60, this is 20, and the entire thing here is your 60, and this is your 20. I think that's what you need, 60, 20, 20. So now you have to find the moment of inertia. Just give the dimensions a little bit better. Okay, 60, 20, 20 is this one. Okay, so find moment of inertia. So you can just do this, and write your answer of Ixx, right? Ixx and Iyy in the comment section. Okay, in the comment section you can write, and then I will tell you whether this is right or wrong.